So I welcome you all in today's session of hands-on Python programming. And in today's session, we are going to discuss about Scikit Learn Library. Okay. So let me tell you a few basic points about Scikit-Learn. That Scikit-Learn is the most useful and robust library for machine learning in Python, and it provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction via a consistent interface in Python. So, as we know, that it is most useful and robust library, especially when we are going to do some machine learning project. Okay, and why it is so popular? Because it provides a variety of functions. Okay, uh, that will help you to do, if you are going to do any project that involves classification, regression, clustering. So all these terms we will discuss in detail also. So if your project involves these type of situations or problems, then you can use this Scikit Learn library because it provides a variety of functions to do these type of projects. So its name stems from the notion that it is a scikit or scipy toolkit. So that's why its name is scikit, and separately developed and distributed as a third-party extension to scipy. And the original code base was later rewritten by other developers. So it is an open source actually library. So many we can say contributors are there for this library, and it is the most popular machine learning libraries on GitHub. And this library, which is largely written in Python, is built upon NumPy, SciPy, and Matplotlib. So the base of this library is NumPy, SciPy, and Matplotlib. Next, we will talk about a few basic things about machine learning. That what do we mean by machine learning? So, especially machine learning is building machines that can adapt and learn from experience without being explicitly programmed. So, what do we mean by this sentence? Let me tell you in simple words that if you will write a program to do something, that machine can do, obviously, okay, there is no problem in that. But what we want to do, that machine should learn from data, and without program, okay, without program, it should be calculating something, it should be predicting something, we can say. Okay, so from analyzing the data, if our machine is able to do some prediction, okay, able to find some values, okay, or able to find the category of some article or some values, then we can say that we are actually working on in the domain of machine learning. So in general, in most of the machine learning projects, actually there will be a learning algorithm, okay, and data set will be there. So that data set we can divide in training data set, okay, and test data set, that will be fed to a learning algorithm. So we will talk about this learning algorithm. So learning algorithm actually draws inferences from the training data set. So whatever data set that you will feed, okay, to your learning algorithm, so that learning algorithm will draw some inferences. It means it will learn from that data set, okay, and it generates a model which is a function. Actually it will be a function that maps input to the output. So whenever you will train your data set, after training you can use this that model, okay, to get some output for some particular input. Okay, so that will be, we can say, a workflow of any machine learning model or machine learning project. So if you will go for the categories of algorithms that we use in machine learning, so broadly we can classify in supervised learning, unsupervised learning, and reinforcement learning. So at this point, let me ask that, do you have some idea, basic idea of this supervised learning, unsupervised learning, and reinforcement learning?
Yes, sir.
Okay, so could you tell me what do we mean by supervised learning?
In the supervised learning, sir, already the data is given, I think. Data is already
Okay,
there.
fine,
So
fine.
we are going to find out the optimized data, and that should be almost equivalent with the whatever the data is already fed into the system.
Okay, fine. Sare?
मतलब
Yes, 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 yes. Please tell me. Yes, Deepika. So supervised means we are actually providing data, okay, with the output levels also. Okay. So Sarim,
Yes, sir.
am I audible? So
Yes,
do
sir.
you have some idea about these terms, like what is supervised learning, what is unsupervised learning?
Sir, very little.
Yes, whatever you know, you can share.
Sir, in unsupervised learning, we don't have any answer or how will the outcome will be. In supervised, we know the answer.
Okay.
And in reinforcement, we tell how to teach, how the pattern will occur, and we teach it.
Okay. Okay. That's fine. It is close to the actual one. But let me actually tell you about these terms, okay, with the help of one example. For example, there is a kid, okay, and if you have few coins, for example 5 rupees coins and 10 rupees coins, okay, so if you are going to teach the kid to find that whether it is 5 rupees coin or 10 rupees coin, so what you can do, you will simply show few 5 rupees coins and you will tell that these coins are actually have less radius, okay, if we will compare with it a 10 rupee coin, okay. So few features you will tell that its radius will be less. It's we can say if radius is less, it means its circumference will be less. Okay. So for 5 rupee coin and for 10 rupee coin, of course, radius will be greater one, and of course, then circumference will be also greater one. So what we can say that if you are telling the radius, circumference, and also that this one is 5 rupees coin, okay, then another 5 rupees coin you are taking, and again you are telling that this is radius, this is circumference, and this is 5 rupees coin. So because we have a variety of 5 rupees coin also, because there will be little bit changes in even if you have few 5 rupees coins, okay. Same we will do for 10 rupees coins, that for 10 rupee coins radius will be little bit greater if we will compare it with 5 rupees coins, and of course circumference will be greater, and it is a 10 rupees coins. So if you are going to tell radius, circumference, and if you are telling that it will be 5 rupees coins, it means label also you are going to tell, then it will be supervised learning, okay. It means you are supervising about the final output, final target, that this will be a 5 rupee coin, this will be a 10 rupee coin, okay. So the thing is that if you are going to tell that this will be radius, this will be circumference, and then it will be 5 rupee coin or 10 rupee coin. So if you are going to tell that final level that it is 5 rupee coin or 10 rupee coin, it means you are actually providing that final output level also. Okay. And after teaching all those things in this way, after that, if you will take a new another 5 rupee coin or 10 rupee coin, and you will give that to that kid, that same kid, okay, and you will ask that which coin it is actually, okay. So what he will do, he will try to compare it that it is less radius or we can say large radius, okay. It will that kid will check that it is of low circumference, or we can say small circumference, or big circumference, large circumference. So he will just try to map the things, and he will just try to recall that what I actually learned from the data that has been provided, okay. So after that, that kid will predict that this is a 5 rupee coin or 10 rupee coin, okay. So if you are telling that this is radius, this is circumference, and then it will be 5 rupee coin, so it means you are actually working in supervised learning fashion. But if you are going to teach the kid in a different manner, what you are going to do, simply you will tell that this will be radius, this will be the we can say circumference, okay, for some coins, and this will be the radius and this will be the circumference for some other type of coins. If you are not going to tell that exact category or exact label, okay, that it will be 5 rupee coin or it will be 10 rupee coin. Okay. So if you are not going to tell that final level, it means actually what you are going to do, you are going to simply provide your data that there are some coins, okay, and you will just give that coin, okay, without telling anything. We can say that this will be the radius, this will be the, we can say, circumference. Simply you will take all 5 rupee and 10 rupee coins and you will give that to kid. That kid will himself try to compare that these coins have less radius, okay, or a small radius and a small circumference, and few coins are having large radius and large circumference. So these two categories we can say for these two, for these coins. Okay. So it may be possible that kid will not tell you that this is 5 rupee coin, this is 10 rupee coin, but what actually that kid is going to do, that all the 5 rupees coins he will just put aside and 10 rupee coins at one side. Okay. So simply he will, we can say, categorize those coins. So if you are not going to provide all these features, and features means radius and circumference, and also the final level, okay, then it means you are going to do the things in a fashion of unsupervised learning. It means you are not going to tell anything that what will be the features and what will be the target, okay, that this will be 5 rupee coin or 10 rupee coin. But if the kid just after looking to those coins, if he is able to segregate these 5 rupee coins and 10 rupees coins, it means actually we are following unsupervised learning. Okay. Next is reinforcement learning. So reinforcement learning, if we will take the same example of 5 rupee coin, 10 rupee coin and a kid, then what we can do, that we will provide a coin, one coin we will take, okay, and we will give it to that kid. And if that kid is trying to, is going to identify that coin correctly, for example 5 rupee coin, if you have provided a 5 rupee coin and that kid has predicted that yes, it is a 5 rupee coin, then what you will give, you will give a candy to that kid, or you will give a chocolate to that kid. Okay. But if that kid is going to predict, or we can say if that kid is going to classify that coin wrongly, okay, or we can say incorrectly, then you are not going to give that chocolate. Okay. So if you have given a 10 rupee coin or 5 rupee coin and kid is identifying it as 5 rupee coin, okay, it means correctly as it is, then you will give a candy or you will give a chocolate. If that kid is not going to predict the category of the coin correctly, then you will not give what? Candy. Okay. So actually that will be the style of reinforcement learning, that whenever that model, that we can say algorithm is going to predict correctly, then it will be rewarded, otherwise it will not get any reward. Okay. So it means if kid will predict correctly that yes, it is a 5 rupee coin and actually it is a 5 rupee coin, then you will give a candy to that kid. Okay. Otherwise you will not give the candy to that kid. Okay. So if that will be the fashion of learning, then we can say that actually we are following reinforcement learning. So next we will go for the thing that broadly we can categorize supervised learning also in terms of regression and classification. So quickly we will go through the basic concepts of these terms. That regression means actually the target variable. So to let me tell you about target variable and input variable or features, we can say. So for example, radius of the coin. Okay, if we will take that same example, radius of the coin may be an input feature. Okay, circumference of the coin may be an input feature, but actual value of that coin, for example it is a 5 rupee coin, so that is actually target variable. So target variable means actually we want to find that value. Okay. So, and as an input we are going to use radius and circumference. It means on the basis of, on the dependency of radius and circumference, we will try to predict that what is the value of that coin. So value of the coin will be target variable. Okay. Or for example, if you want to know the price of a house, price of a flat, so you can go for as input features you can take like what is the area of that flat, or carpet area, we can say how many bedrooms are there, okay, what is the location of that flat, okay. So these will be the input features. On the basis of these features, actually you will try to know the price of that flat or price of that house, okay. So these will be this number of bedrooms or location of that house, okay, or carpet area, or we can say simply floor area of that house. These will be input features, and on the basis of these input features, or we can say dependent features, okay, we just want to find the target variable, that will be the price of the house, okay. So in regression problems, actually target variable will be having a continuous value, okay. Continuous value means, for example, price of a house may be any continuous value. It will depend on the few features, okay, and it will be a continuous value. It means we can say for if you have 2 bedrooms in a house, and carpet area, for example, 900 square meters, then you have some price of, for example, 5 lakhs of the that house, okay. Price of that house is 5 lakhs, okay. So like that we can continuously find that target variable, okay. But in case of in case of classification, we will have some categories, and we have to pick among those categories. For example, if we have few emails, okay, in your inbox, and you can categorize them as spam or not spam, okay. So we have only 2 categories here. So like that, if you are going to classify in different categories, it means you are actually dealing in the domain of classification. Otherwise, if you are going to predict some continuous value, so then we are going to deal in the case of regression, okay. So that is the basic difference between regression and classification. And next we will go for unsupervised learning. So regression and classification, okay, then we will go for unsupervised learning. That I already told you, that if you are going to train your model with the help of unlabeled data means final label or final category, if you are not going to tell, then actually you are using unlabeled data. It means you are providing coins to kid, but you are not telling that which coin is 5 rupee coin and which coin is 10 rupee coin, okay. So this 5 rupee and 10 rupee, these labels, if you are not going to use in this example, then actually you are using this unlabeled data. It means you are working in the domain of unsupervised learning, okay. So in unsupervised learning, you will provide that data, and that learning algorithm will automatically classify that these are 5 rupee coins, these are 10 rupee coins. So that category, we can say that will be a cluster 1, that will be cluster 2, that will be cluster 2, cluster 3. So it will uh, classify your data in different clusters, we can say, in unsupervised learning, if you will talk, okay. So next, I'm just going to tell you that what machine learning algorithms we can use, and in which actually category it will be. So if we will broadly classify, as we discussed, that we can classify machine learning algorithms in supervised learning and unsupervised learning. And supervised learning further we can categorize as classification and regression. So for classification problems, these algorithms we have, for example, k-nearest neighbor, naive Bayes algorithm, and decision tree algorithm, support vector machine, logistic regression. So all these algorithms actually we can use for classification, and discussion of these algorithms, okay, we will do in next sessions. But in this session only, we are going to know about the categories of algorithm that we can use in different type of machine learning problems. So for classification, we use these KNN. In short, we can say k nearest neighbor, naive Bayes, and decision tree, support vector machine, logistic regression. So these algorithms we can use for classification problem. And for regression problem, like I told you, for house price prediction, We can use linear regression problems, support vector regression, decision trees we can use for regression. So you can see that decision tree is common for classification regression. So that is the we can say extra feature of decision tree, that we can use decision tree algorithm for classification problems also, or for regression problems also. And there is another one, Gaussian progress regression. Ensemble methods we can use for regression. So ensemble method is a different category, so we will discuss in next sessions. Next, for unsupervised learning, okay, that is actually we can say the problems in which we want to do clustering. So for that we can use Gaussian mixtures, k-means clustering, boosting algorithms, hierarchical clustering, spectral clustering. So details of all these algorithms actually will be little bit technical also, and it will take, I think, for one algorithm we need one session. Okay, so that is out of the scope of today's session. So that's why at this point of time you should know only the name of algorithm that we can use, or name of machine learning technique that we can use for different type of problems, okay, like classification, regression, and unsupervised learning, or we can say clustering. Okay, so we can use these type of algorithms. Next, I'm just going to take a project in which we will do classification, okay, on iris data set, and we will use this decision tree algorithm. So first of all, let me tell you that what actually we have in iris data set. So this is a sample, few sample records we have from iris data set. So it will tell you about the type of iris flower, okay, and how it will tell you about the what we have in this iris data set about iris flowers. So it will actually, each record will contain some values for sepal length, sepal width, petal length, petal width. So you can see that what do we mean by petal. So this portion of the flower actually represents petal, and this type of we can say leaves, okay, or a structure in our flower, that will represent sepal. Okay, so for petal and sepal, so sepal length, sepal width, and for petals also petal length and petal width, we are going to have in this iris data set. Okay, and what we have extra as a label, that I told you, label means final category or class of that flower. Okay, iris flower. So it belongs to setosa or versicolor or virginica. So these three we can say types of iris flower categories we have. Okay, so let me tell you in simple words that these sepal length, sepal width, petal width will be input features. Okay, and on the basis of these input features, actually we want to know that that flower belongs to which class, or which we can say type of iris flowers. So if sepal length is 5.1, sepal width is 3.5, petal length is 1.4, petal width is 0.2, then it will be a setosa. Okay, so this type of records we have, total I think 150 values we have. Okay, so this will be our data set that we will use for a classification problem, where we will use this Scikit Learn library. And classification, as we discussed, that for classification we can use any one of these algorithms. So decision tree is one of them, so we will use this decision tree algorithm. And in simple words, let me tell you that what actually we mean and we actually follow in decision tree. So decision tree are non-parametric supervised learning method used for classification and regression. So we can use this for classification problems and regression problems also. And it is a non-parametric. It means there are no parameters. We don't need to use particular parameters. And the goal is to create a model that predicts the value of a target variable. So what we actually want to do with the help of this decision tree, we want to create a model. What it will do, that model will do, it will predict means try to find out, guess the value of target variable. So what is the target variable in this iris data set? This type of iris flower, like setosa or versicolor or virginica. Okay, so on the basis of this sepal length, sepal width, petal width, okay, on the basis of the values which we will have, okay, it will tell you, or it will predict the type of, we can say, iris flower. Okay, so for which we want to create a model. Okay, so if we will take another example, okay, to just to have an idea, basic idea of this, we can say, decision tree algorithm. So we can say that there will be few criterions, and on the basis of few criterions, we are going to select that a particular bank should give a loan to a particular person or not. Okay, so for this type of problem, we can design a decision tree. Okay, just for example, to have the basic idea of decision tree. So what is the scenario? So for a person, we want to know that the bank should give loan or not. Okay, the person should get a loan or not. Okay, so it may be one criteria that first of all they will check, the bank person will check age of that person, okay, to whom that loan should be sanctioned. So if age is over 30, it means age is more than 30, so that we will check first, okay, as a root node. Okay, decision tree means tree like of tree like a structure we will actually draw finally. So we will start from somewhere. So first criteria may be the age, like age is more than 30 or not. Okay, so if it is more than age over 30, no means less than 30. Then they will check that salary over $2,500 or not. So then they will check that what is the salary of that person. So if salary is more than $2,500, okay, as we have taken here, so you can see yes, then he will get loan, he or she will get loan. Okay, if that salary, if the salary of that person is not more than 2,500, then don't get loan. Okay, okay, so this was one subtree of this final decision tree, one subtree we can say, or left subtree we can say. But if that age is greater than 30 or over 30, okay, that criteria is yes, then they will check that number of children is less than 2 or not. Okay, so if number of children is less than 2, yes, then get loan. If number of children is greater than 2, not less than 2, it means no, then don't get loan. Okay, so this on like this, actually on basis of some criteria, we are going to divide our we can say records. Okay, or we can say our data. Okay, and finally we will try to predict, okay, on the basis of these leaf nodes, that whether that person should get a loan or not get a loan. Okay, not getting a loan. Okay, same we can draw a decision tree. For example, what is the weather situation or weather conditions? On the basis of that, the final level, or finally we will try to know that it is good to play golf and it is good to go outside to play golf or not. Okay, for example, first of all it will check outlook. Outlook means it is sunny or overcast or rainy. So what is the weather we can say on that day. Okay, now if it is sunny, or we can say if it is overcast, so in overcast we don't have any problem, it is not too sunny, not rainy, not too rainy, so it is that weather is, we can say, suitable for playing golf. So if it is overcast, so simply yes means we can play, we can go outside and we can play golf. Okay, if it is sunny, then we will check that what is the humidity. If humidity is high, then don't go outside, it means don't play golf. And if it is normal, then we can play golf. Okay, for rainy season, we will check that what is, it is windy or not, it means what is the wind speed we can say. So if it is windy, it means wind speed is high, then we should not go outside and we should not play golf. And if it is false, it means it is rainy but it's not windy actually, so then we can play golf. Okay, so like that we can create a tree, decision tree we can say. Okay, so this type of structures actually we are going to follow, but little bit technically we are actually, we will, decision tree will use actually few parameters like Gini index and entropy. So these are actually, we can say, mathematical terms or parameters that will simply help this decision tree algorithm to find the final level of that record. Okay, so you can see that there are some mathematical formulas, so that we can discuss whenever we will be discussing this decision tree in detail. But at this level you should know that there are few parameters like Gini index and entropy. Okay, so these are criterions, Gini index and entropy. For calculating information gain is the parameter on the basis of which actually it will split a node, like it will go to yes or no. Okay, so this type of thing is going to be decided on the basis of the value of Gini index. Information gain, and information gain is actually we can calculate on the basis of the Gini index value and entropy. Okay, so for which we have some mathematical, or we can say, formulas and functions also. So that is not the scope of this session, that's why I'm going to skip. But whenever we will be discussing if decision tree in detail, then we have to go all these things mathematically also. But at this stage I am uh, going to next slide simply. So if we will talk about that, if we are going to apply this decision tree, so what actually a decision tree representation for our iris data set. So what it will do, it will check that petal length is less than 2.6 or not, less than equal to 2.6 or not. If it is less than 2.6, then on the basis of some calculations, as I shown you that these are mathematical formulas, so on the basis of these mathematical calculation, it will calculate the Gini value, like 0.666, how many samples are there, value is what, then class is what, setosa. Okay, so it is true or false. So like that, we are actually, if we will apply this decision tree, then we can say this type of decision tree will be created. Okay, but here and for this session, we will simply use this decision tree classifier from Scikit Learn Library, Sklearn Library, and we will directly apply those things. So it will be just like a black box at this level for this session. Okay, but internally it will be implementing this type of decision tree. So for this session, as the motto or objective of this session is about to is to learn about how we can use this Scikit-learn or Sklearn library, okay, for any machine learning project. So we will go to our Jupyter notebook or collab file, where we will start writing the things for this problem. So let me tell you that what is the problem for today's session, that we are going to deal in classification on iris dataset using decision tree algorithm or machine learning technique, we can say. Okay, because in iris dataset we have this type of data, and on the basis of this data we want to find that what is the class of that iris flower, so whether it is setosa or versicolor or virginica, that we want to know. So it is not a continuous value. Okay, so it is actually only three types we have, so three classes we have. So it is a classification problem that we are going to apply for famous iris popular data set. It is a very popular data set. Okay, so you can get this data set from UCI repository or Kaggle repository. Okay, so we will use this decision tree. We can use any other classification algorithm also, like SVM also, but for this session we are using this decision tree. So this was, we can say, introductory idea about this problem that we are going to deal in today's session. So I hope till now slides are visible and I am audible properly also.
Yes, sir.
Okay, thank you. So now we are going to, first of all, let me tell you that how we can install Scikit-learn. If you are using especially Jupyter, then you should use this command, pip install scikit-learn. So with this command you can install Scikit-learn in Jupyter. If you are using Google Colab, so there is no need to install it, you can directly use with the help of import command. Okay, so first of all, what we are going to do, we will import these libraries, because for this project, for this classification project, we are going to use this one. So what I am going to do, that simply we will import these two things, import pandas as PD, import numpy as NP. Okay, so I hope you have no confusion regarding these two libraries, as we have discussed in earlier sessions, that this is to import pandas library and next one is to import numpy library. Okay, so we are going to use these libraries, that's why we are importing here. So next we will go for, so you can start doing this coding at your side also, if you are using Jupyter or Colab, whatever. So you can start writing these codes. Okay, so next we will import this iris data set and accuracy score. Okay, so you can start writing, or if you will say that I will share this code with you also, if you want, then I can share this code first. So then you don't need to type, you can copy paste directly the things, so it will save your time. So what I am going to do, so what will be the convenient way if I want to share all this code with you, but stepwise, or we can say line by line, we will discuss these session, these lines, actually this Python code. So will you be able to access this code here if I will directly sharing it to our, we can say, in chat box? Okay, Sarim, are you able to get it
Okay,
from the chat box of our meeting?
okay, okay, sir.
Deepika, or should I
No,
share
sir.
it to WhatsApp?
Yes, sir. Share me
Okay,
with
okay,
on WhatsApp.
okay, okay. I am going to share this on your WhatsApp.
Then share with me also on WhatsApp, please.
WhatsApp, okay, okay. So I will share it to your WhatsApp. Copy selection, then WhatsApp. Sorry, so just check. I shared to your WhatsApp also. So what you can do, just you will copy paste only first 4 lines, okay? Then we will have a discussion of these 4 lines. Then we will go to next line of code. So first 4 lines you can copy, in which we are going to import pandas library, numpy library, and iris dataset, and accuracy score matrix actually. So
It's written from Sklearn. So
yes, yes, yes,
directly we are copying this, sir.
yes, you can copy. But
But
before that,
sir,
you have to ensure that you have used this pip install scikit learn command.
uh, s- sir, we have already used this command. After that, I have written import numpy as PD, import pandas as PD. Then after I have written sklearn dataset, import load. Everything I have written, but it is discussed in the previous class.
Okay, fine. So just load these 4 lines and try to run. I think you will not get anything as output, because here only we are importing.
Okay.
Okay, so
Yes, sir. Done.
okay, so let me tell you that what do we mean by actually this from sklearn dot data set. So actually sklearn, that scikit-learn library that we are going to discuss in today's session, actually we are discussing about that. So sklearn represents your scikit-learn library, okay? Then dot data sets means actually scikit-learn library itself, contains a number of data sets, and from that datasets module we want to import only load underscore iris. It means only iris dataset, okay, we are importing. So from that datasets module, we are actually importing this iris dataset, for which we are writing import load underscore iris. But then Python interpreter may ask that from where I should import. So it should import from. So you can see that from sklearn.datasets, because in sklearn library we have datasets module in which this iris load underscore iris dataset is there. So from there it has to be imported. Okay. Okay, next we have from sklearn.matrix. So matrix means we have some standard parameters to evaluate our machine learning model. For example, if you have created or developed a machine learning model, so it is performing well or not, okay? It is performing good or bad. So for evaluating that model, we have few metrics, okay? So in among that metrics, one of the metrics is accuracy. Accuracy means how accurately it is going to predict the actual class. Okay. So we are actually importing here this accuracy underscore score. So accuracy is one of the metrics that we are going to import, and from where it has to be imported? From Scikit Learn Library, in which we have metrics module. Okay, from that it has to be imported. Okay, so I hope you got the, we can say, basic concept behind importing these things. Okay, in these two lines.
Sir, it is when we are accessing the library, so we are writing like this.
Hmm.
Suppose we have some data, so we are going to access that. Whether it is imported in the library, then after it will be called.
No, 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 no. If you have your data set, then that data set you can you uh, you can import in a data frame with the help of that read CSV, as you can recall,
Okay,
that function that we discussed in pandas
okay,
library. So like that you
okay,
have to import if you are
okay,
importing your CSV file. Okay, like that. But here actually we are using that iris data set directly from scikit learn. Okay, we are
yes,
not going to import it, we can say, externally. Internally actually we are importing from sklearn.
okay,
Okay, so
okay,
if you
okay,
have your own data set, for example, then you have to go like that we used for the session in the session that was related to pandas. Okay,
okay.
so in that we actually imported titanic data set. Okay.
Yes, that we have done, but we have not gone through the different classification. Like we have not used the regression analysis for
Okay.
the.
Okay. So at this
So
point of
how?
time, let me tell you that in the same way you can use that thing here also. Okay. So next, probably we will try to do it. Okay. That this iris data set we will download externally, and externally we will try to include or import in our program. That also
Okay,
we can do.
okay,
The same
okay,
procedure will be same. Okay.
okay,
Okay, so but this iris data set we have already have in scikit-learn. That's why we are importing here directly. Okay, next what we are going to do now, we will this read this CSV file. Okay, so we have imported this data set from scikit-learn. Okay, now we want to read this, we can say, iris data set. So for that, what we have to do, so that you can write data, so you can skip this comment line at your side. You can skip this comment line reading the iris.csv file. So at this line of code, actually simply we are, okay, reading this iris data set. Okay, and we are going to store it in this data. Okay, so let me show that what is the actually type of our data. Okay, so it is a scikit-learn utilities bunch. Okay, so it will be stored in this bunch. Okay, so our whole data set, or we can say whole data, will be copied to this bunch. Okay, so it will be same like we have just copied the data set of titanic data set in our pandas data frame. Okay, so same type of thing we are going to do here, if you can recall. So we don't need to keep it here. So I'm just going to remove this. But actually what we are going to do here, that all the data that we have in that iris.csv file, okay, in that data set, all that data will be copied to this bunch. Okay, data. Okay, so all this data, we can say records, we will have in this bunch data. Next what we are, so if you have any confusion regarding this data, you can ask. Otherwise we can say that same thing that we did, that titanic data set we actually copied in a data frame. Okay, so same type of thing actually we are doing here, but we are going to copy all those things in data that is actually a bunch, okay, of scikit-learn's utilities module. Next, let me tell you that what we have in data. Okay, so that we are going to show here. So what we have in data. So what we are going to do that in data, that iris data set, let me show you this figure. This is for iris data set. So what actually columns we have there? So column is sepal length, sepal width, petal width. These are the columns. Okay, and then we have class level. Okay, as a column also. Last column is class level. So in which this sepal length, sepal width, petal length, petal width, all these columns will be used as feature. This class level will be used as a final target feature, or we can say target level. Okay, it means we want to predict this class level, but these sepal length, sepal width, petal width, these columns will be used as input features. Okay, so here what we are going to do that in capital X, okay, we are going to just store these input features. Input feature means sepal length, sepal width. Okay, all these things we are going to store here. So if you will print that what we have in X, so that you can see. So you can see that in X we have this type of records 5.1, that is, for example, we can say sepal length, 3.5, that is sepal width, then 1.4, it means petal length. Okay, then sorry, petal length, and then 0.2 for first record if we are discussing. So 0.2 is what? Petal width. Okay, so only these first four columns we have. Okay, data dot data, so that we stored in X. Okay, so I hope you got that in X we have only input features. Okay, so next I am not going to use to print this thing. So X will contain only input features. So what do we mean by input features? Only first four columns. This sepal length, sepal width, petal width. Only these values will be there in capital X. Okay. So I hope you got this point. Next, what we are going to do that extracting target or class level. It means final column we want to get. So we are just going to put it in Y. Okay, so this is capital X and this is small y. Small y, in small y, what we are going to put? Data dot target. So what is our target column? Target column is actually this one, in which we have the name of the iris type. Okay, type of the iris flower, like setosa, versicolor, or virginica. What is the type of that iris flower that we have stored in that column? Okay, so if you will see that what we have in Y, so let me show you. Sorry, small y. So in a small y, we have this 0, 0, 0, 0, 1, 1, 1, 2, 2, 2. So let me tell you that 0 will be used for first category, 1 will be used for second category, 2 will be used for third category. So only 3 categories we have. So it will store in terms of 0, 1, and 2. Okay, so let me show you that which one will be 0 and which one will be 2. So that also we can show with the help of, there is a, can say, data dot target. Okay, so that also I will show you. Okay, so for which we can use this data dot target names. Okay, so data dot target names, if you want to know the names, not in terms of 0, 1, and 2, if you want to know the names for this category, like 0 represents which category, exact name you want to show, then you can use this. 0 will represent what? Setosa. Second one is versicolor, so it will be 1. Then third one is virginica, it means it will be 2. Okay, so I hope you got this thing, but we are not going to keep this thing here. Simply in Y we are going to store the last column. Okay, so now let me tell you that in small y we have what? This last column, all the values that we have in last column. Okay, all the values, not only one value. Okay, so this whole column will be stored here, okay, in small y. So I hope all the points are clear till now. Now we are going to use import library for splitting data. Okay, so what we are going to do in next line of code, that we are going to import a library, okay, whose where we want to split our data. So what do we mean by splitting data? Okay, so if you have some idea, you can tell what do we mean by splitting data. So for example, in iris data set, you have 150 records. 150 record means this one is first record, for which you will have sepal length, sepal width, petal width, and class level. So this is first record. Similarly, we can have, for example, if we have 150 records, okay, okay, or just for simplicity, if we will take, we have only 100 records, okay, then what we are going to do in splitting data is, splitting data means just we will split our data set, okay, or this complete data, we can say table, in two parts, okay. First one will be used for training phase and second one will be used for testing phase, okay. So how we will split? So what we will do, we can do with like 80-20, in 80-20 portion. So first 80 records will be used for training phase and last 20 records will be used for example, testing phase. So what do we mean by testing phase and training phase? So in training phase, actually you will provide all these columns, okay, it means last one also, class level also, for your, we can say for this, for your model, okay, for your to your algorithm like decision tree we are using. So first 80 complete records will be provided, okay, and at the time of testing, what we will do, at the time of testing, only first values for first four columns like 5.9, 3.0, 5.0, 1.8, it means only sepal length, sepal width, petal width, only these values will be given to our model, and model will tell that what is actually class level. It means model will tell that it is setosa or versicolor or virginica, or if we are going to represent in 0, 1, 2, then model will tell that this is actually category 0 or category 1 or category 2. So 0, 1, 2 means setosa, versicolor and virginica. Okay, we can represent that with the help of 0, 1, 2. Okay. So in training phase, model will tell you, but in testing phase, you will tell all those things like sepal length, sepal width, petal width, and class level also to your, you can say, algorithm like decision tree we are using here. Okay. So I hope this training and testing on splitting of data set is clear at your level. So for that, we are going to import library for splitting data. So in sklearn.model selection, so from model selection, we are importing train underscore test underscore split. So this library actually we are importing, okay. And from where we are importing? From module model selection of Scikit Learn library. Okay. So this is again another library we can say that we have in Scikit Learn. Okay, so train test split we are going to import. So train test split, where we will use this thing for splitting our data set. Okay, so in next we can say line, we are actually creating train and test data set. So we have complete data set. Now we will split our data set in training, we can say set, and testing data set. Okay, two parts we can say. So first we have x underscore train comma x underscore test. Okay, so capital X underscore train will be the X portion. It means only input features will be there for training, and X test means only input feature for testing phase. Okay, Y underscore train means the labels that we will use at the training phase, and Y test. So Y test that class levels or type of flowers we can say we will have, okay, that actually model will tell you, you will not provide it, okay, at testing phase. Why test? You will get as a result, okay, as a prediction from your model. So these four, we can say, portions we will get after splitting, okay. And we are going to use this function train underscore test underscore split. This is a function that we are going to use, okay. And here what we will provide as input, so x, capital X, so capital X is what? Capital X is all your input features, okay. Okay, small y is your we can say target feature, target levels, okay. So types of flowers we have here. And random state is equal to 50, so that is a parameter that we have to use, like random state is 50 or 20, so it will use, okay, to we can say for random state. So let me tell you a few more things if you want to know in train test split, okay. So before that, let me tell you about test underscore size. So test size is 0.3. 0.3 means 30%, okay. So test size will be 30%. It means 30% data will be used, sorry, 0.3 means what you left for training, 0.7, okay. If you will compare, if you will minus this thing from 1, so 1 minus 0.3, 1 minus 0.3, it means 0.7. 0.7 means 70% data you will use for training, okay, and this is test size. It means 30% data you will use for testing. So if you have 100 records, for example, then 70 records will be used for training and 30 records we can use for testing, okay. So in this way we can split our data set in train and test data sets, okay. So about this random state, we can check this thing in Sklearn library. So this random state, what it is going to tell you, that random state, okay, controls the shuffling applied to the data before applying the split. It means what it will do, it will simply shuffle your records, okay. That is something like that, shuffling the cards before actually distributing your cards whenever you are playing cards, okay. So it will shuffle, we can say, your records, okay. So for that we can use this parameter random state. For that you can use 50, so 50 times it will shuffle. Otherwise you can use, for example, 40 also, okay. So it will not matter at this level. So you can simply keep in mind that random state with some value you have to use. And test size 0.3. 0.3 means train size will be 0.7. It means 70% records will be used for training, and test size is 0.3. It means 30% records will be used for testing, okay. So what next actually we are going to do, now we are going to use this decision tree classifier. So we will build a model here. So I'm going to do this thing. So I hope at your side you are also doing this thing at your level and you are not getting any error. So what we are going to do, so let me run all these cells one by one. Then this, then this, then this, then this, then this, and then this one, okay. So decision tree classifier actually we are using. So in this portion, what we are going to use, we are going to use decision tree classifier. So from sklearn.tree, so tree is a module there where what we will import, decision tree classifier. This library we will use, okay, import, and then decision tree classifier function we will use, and this classifier or function we will store in this CLF, okay. So what is the type of CLF that we can check, that what is the type of CLF actually. So CLF is actually decision tree classifier. This whole function will be stored in CLF. So wherever you will write this CLF we can say for classifier. So CLF will represent this complete decision tree classifier. So we don't need to write this long name like decision tree classifier. We will use only CLF. So that we can say simply we are going to create an alias for that. Okay. So wherever we will write CLF, it will represent that complete decision tree classifier function. So next what we are going to write, CLF dot fit. Fit means actually we are fitting our data. It means we are training our data. Fit means we are going to train our data. So at the time of training, we have to use only X train and Y train. Okay, so that's why you can see that only these two parameters we have used, CLF dot fit X underscore train comma Y underscore train. Okay, so that we are going to use here. So it will give you only that decision tree classifier. So it means name of the classifier that has been fitted or that has been used, okay, at this level. Next, what we are going to do, predict accuracy score. So what we want to know, now we are actually in testing phase. Okay, now we want to test our data. So at the time of testing, we can simply use test portion or test data set. So what we are going to do next, that we are going to find accuracy score. So y predict is equal to CLF dot predict X test. So what it will do, simply it will predict, okay, for testing part in which you can see that X has been divided in X test. It means only 4 features we will provide. Only first 4 columns we will provide. That final type of flower, that column we will not provide here. Only X test we are going to provide, and we are going to just predict. And whatever it will predict, it will be stored in YPRED. YPRED. Okay. So whatever will be predicted, that we are going to store in YPRED column, we can say. So next what we will do, we will check that what is actually accuracy score. If we will compare it with Y test, because in Y test we have actual values and in YPRED we have predicted values. So what actually YPRED will be having? YPRED will contain the values that our model, this decision tree classifier, okay, will predict. Okay, but where is the actual value? Actual value from data set has been stored in Y test. Okay, it means actual type of flower, for example 0 or 1 or 2, what is the category of flower, actually from data set we have in Y test, but our model is telling, okay, that we are going to store, what our model is telling, that we are going to store in YPRED. Okay, so next we are going to print that what is actually accuracy score. So accuracy score function we will use, in which we will use Y true is equal to Y test. It means Y test will be one function and YPRED is equal to YPRED. YPRED, we can say that prediction values will be compared with the test values. Test values means actual values. Okay, and on the basis of that, if it will be, if for example for first record it will be same, then for it will check for second record, then third record. Okay, so for example, if out of 10 records, okay, prediction and actual values, okay, are same, for example only for 6 records, then it has low accuracy score. If in another situation, if you are getting the same value for prediction and accuracy, for example for 8 records or 9 records, it means accuracy is more there. Okay, if you have two situations, for example predicted value and actual value you have, okay, and you compared that thing, so you found that out of 10 records it is same only for 6 records, and in another situation you compared those two things, predicted and actual, and you found that, for example for 10 of out of 10 for 8 records they are same, so it means accuracy is more in second situation. Okay, so that is the basic concept of accuracy here, but that will be calculated mathematically here. For that actually it will use the concept of confusion matrix, that is beyond the scope of our session, this session actually. And in confusion matrix it will try to calculate actual values for true positive, true negative, false positive, false negative. So that is also that we can that will be calculated mathematically. And for accuracy we have particular formula. For example, accuracy, if you will check accuracy in terms of TPTN, okay, so then you will find that there is a mathematical formula on the basis of that. we can calculate this accuracy. So TP plus TN upon TP plus TN plus FP plus FN. Okay, so that is beyond the scope of this session. That's why I'm not going into detail of that. But let me tell you only one thing at this point of time, that we have a particular formula to calculate this accuracy. Okay, mathematical formula we have. So there is nothing type of guess. Okay, so mathematical formula is that, and that will be calculated automatically if you will use this accuracy score function, and you will provide these two things, test y test and y pred as a parameter, then it will calculate for you and it will tell you. Otherwise, if manually if you want to learn, then you have to learn about confusion matrix, then the parameters that actually from confusion matrix we can get, like true positive, true negative, false positive, false negative, and we have mathematical formula, and by using that formula we can calculate that thing manually also. Okay, but all those things is going to be calculated for you with by this accuracy score function. Okay, this accuracy score function. So in simple words, you can say that what is the accuracy? It means how accurately your model is predicting. Okay, that is going to be tell you with the help of this accuracy score function. Okay, now let me show this thing. Y pred is not defined. Where is y pred? Okay, so let me check that what is the issue for y pred. Or what we can do, simply we will run these cells one by one, then we can see. Okay, so y pred, I think I missed to run this cell, that's why we got that error, but now it has been resolved. So you can see that test data accuracy is 0.955. It means 95% accuracy. It means out of 100 records, it is, if you are going to use 100 records for testing. Okay, for testing, if you are using 100 records, then for 95 records it will predict, okay, correctly. It means what actual values you have, that will be in predicted values. Okay, or predicted, we can say, classes for 95%. So 95% accuracy, we can say we have achieved with the help of this decision tree classifier. So what we can do, we can do some changes in testing size and training size. For example, if we will put 0.2 here, 0.2 as a test size means 20% records will be used for testing, and rest 80% will be used for training. So if you will change this thing, then you can see that what we are getting. So now we are getting 0.966. It means 96% accuracy has been, we can say, increased. So accuracy is increased. So like that, you can do some changes, and you can see, for example, if we are going to put 0.6. So 0.6 will not be better, 0.4 we can see. So 0.4 means 40% data we will use for testing, and rest 60% we will use for training. Okay, so we are going to run. Now you can check. So same, we are getting 96. Okay, or we can do this thing 0.33. Okay, so 0.33, it means 33% data will be used for testing, and rest will be used for training. Okay, so that you can do 100 minus 33. So 100 minus 33, let me know that what is 100 minus 33. Could you calculate? It means around 67%. Okay, so 67% data will be used for. So now let me check that what we have. So now we have exactly 0.96. Okay, so 0.96% accuracy. Okay, so if you will change this testing and training data size, then you will find that accuracy will be different. Okay, so that was the accuracy of our model that we created using this decision tree classifier. So model is your complete, we can say, model we call this complete code that we are going to write. Okay, but that classifier or algorithm will be decision tree classifier, because in a model you can use more than one classifiers also. Okay, that we can discuss in another sessions. But model means your actual thing that you use for classifier, train, test, all those things will contain. It means we can say these two cells, okay, tell about our model, in which we have train and test. we created train and test data sets. Okay, so this is also the part of our model, that what percentage we are using for training and testing, and which classifier we are using for this prediction. Okay, so all those things will actually create your model. But if you will talk about only classifier, so classifier is exactly decision tree classifier, but this complete environment, we can say, will be our model. Okay, so there is bit difference between model and, we can say, actual algorithm. So algorithm is decision tree classifier. Okay, or technique is classifier, but this complete thing, that is information about train test size, okay, and splitting that thing and then applying this decision tree classifier. So this complete this will actually create your model. Okay, because in a model you can use more than one classifiers also. Okay, so here we are using only decision tree classifier, so that is actually the with accuracy 0.96. Now what next I am going to tell you, that if you want to predict, okay, now if you want to predict that thing, for example, copy selection. Okay, so what we want to do, that we will use some values. For example, 2442, 24242 means 2 will be sepal length, then sepal width, petal width. Okay, these values are represented. Okay, now we want to know the category of this iris flower for these values. Okay, so that you can use directly for a particular record also. Okay, so array 1 means that class 1 means versicolor. Okay, so for example, if you want to know the values for class level for 5.1, 3 point, that we have for first record, actually 5.1, 3.5, 1.4 and 0.2. So let me put those values. 5.1. So for example, if you are going to provide this sepal length 5.1 and the sepal width as 3.5, as 3.5. Okay, and then we have 1.4 and 0.2. 1.4, that is, and 0.2. Okay, so I hope you got this point, that what do we mean by these values. So 5.1 represents sepal length, then 3.5 represents sepal width, then 1.4 petal length, 0.2 petal width. So what we want to know, so I want to know the class of this iris flower for which we have these values as sepal length, sepal width, petal length, petal width. So if we know the sepal length, sepal width, petal width values, then on the basis of these values, I want to know, for example, from my classifier, that what my classifier is telling, that which class this flower belongs to. So this is versicolor or vaginica or setosa. Okay, so as you can see here, that this is setosa means it should come 0 for that. Okay, so we are just going to run this thing, so you can say that it is providing you array 0 means first one, that category. 0 represents actually setosa, then 1 represents versicolor, and 2 represents vaginica. So you can try it for the this record 5.9, 3.0, 5.0, 1.8. Okay, so you can try this one also. So
Sir,
in this, yes.
sir, I'm getting errors.
For which line? Last line?
Test accuracy.
Test accuracy. Okay,
Test data accuracy. It is showing accuracy underscore score is not defined.
not defined. Okay. So for that, you have to check that you have imported this thing or not. This line from Sklearn Matrix, import accuracy underscore score. That line you have to use first, because we have to import this from matrix module of Scikit Learn.
Already, it was there in the first beginning.
Okay,
I think
okay.
Sklearn Matrix import accuracy score. It
Okay,
is there, sir.
So what you can do, simply just copy paste that line, okay? Copy
Mm,
paste this line again and check for spelling mistakes. Copy and you just put this thing, okay, before this line, okay, and now try to compare that if there is any typos like typing mistake, like y underscore true is equal to y underscore test comma y underscore pred is equal to y underscore pred. You have used this thing, or is there
yes.
any typos?
1 minute, sir. Yes, sir. Same.
Okay,
C
so
underscore. Yes, sir. Same, sir.
just try to run this thing once again.
I got now. Data accuracy.
Okay, okay, fine.
Mm,
So what is the accuracy at your side?
0.95.
Fine. Now just try to get the accuracy. If you change this test size equal to 0.33, 0.33. Okay. Just change that thing and run all those cells. Okay. After this cell, because you have to run all those cells once again. So run this cell after changing. You have to run this cell, then next cell, then next cell, then next cell. You have to run all the cells. Okay. After that.
Point three three means test size.
Yes, test size is 0.33. It means for
Okay.
testing 30% data, 33% data we will use.
Okay.
So Sarim, let me know that you are getting results for this model, or is there any error at your side?
Yes, sir. Accuracy coming 0.96.
Now it's 0.96. Okay. So
It is
what is
working for me also.
okay, you got this accuracy and test size prediction and all those things correctly?
Yes, sir.
Okay, fine.
So
So
here,
this, yes,
sir,
yes, yes.
here next line, the CLF dot predict. So that is
Yes.
also getting error, sir. Decision
Okay.
tree classifier dot fit missing. One required positional argument.
Okay.
Why
So what you can
missing?
do, that this thing you have to do, I think this line you should copy before this. Okay,
Okay.
like this you can copy, so it will again fit your model or train your model, then you can use this predict function.
CLF dot fit xtrain y train.
Yes,
Then A equal to
x
NP
is
dot.
capital, just check that
Sir,
x should be capital.
NP dot array. Okay.
So check for actually typing typos, that there is no typing mistake, that you have to check at your side.
Sir, once again, show me the page. Sir, I'm getting same error, sir.
Same error. So what you can do, simply you can try this thing, x comma y is
It's showing name NP is not defined.
name np is not defined. Then what you have to do, import numpy as np you have to use. Okay, just do one thing, just copy this line here directly. Okay, and try
NumPy.
to import numpy as np. This may be possible that cell you missed to run. Import numpy
Um,
as np.
okay. So no need to import that, sir.
No,
No
you
need
have to
to
write
write CLF it.
CLF that you can
Omit
say
this one. Okay.
skip. Just make that a comment line.
Import numpy as NP.
NP.
Okay.
NP.
Yes, sir. Array 0 it is showing.
Okay, so array 0 means first class of that flower. Okay, 0 means
Okay. 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 0, 1, 2, 3 like this it will
just
take.
0, 0, 1, 2. Only three categories we have in that iris data set. Okay,
Okay.
so if you will change these values for different thing, for example, for different values, you will get different. We can say for 0, if you will change this thing, for example, 2 only, then and width will be less, so it will be like that. So this will be again 0, so you can make it 3, and then it will be 1. Okay, so 0, 1, 2, out of that you will get any value. So 0, 1, 2 means, let me tell you that what do we mean by 0, 1, 2. So 0 means first category, that is setosa, then 1 means versicolor, and 2 means virginica. Okay, so we can also print directly these things like setosa or versicolor or virginica. So we have to do little bit changes in our code, then it will print directly the name of that type like setosa, versicolor or virginica. Okay, that will be, so that we can do. So for this session, I think it's enough, and we are going to wind up today's session. So this was the simplest, we can say, project. Okay, machine learning based project. You can say that you have completed a machine learning project in which you used classification of iris data set using decision tree classifier. Okay, but let me tell you that few technical things that you need to know more about this decision tree classifier and accuracy metrics and all those things, so that we can discuss, but as per the syllabus that we are going to follow, so as per the syllabus that we are not going to cover here, but in machine learning or any other course we can go through all those things in detail. But at this level you should know these basic things, and the motto of this session was especially that how we can use this Sklearn. So the last question that I want to ask to both of you, that what is the use of this Scikit Learn library, where we will use this Scikit Learn library? Yes, Sarim.
So when we want to fetch the data from the library,
No.
Machine learning.
Yes.
So to train our machine learning models and
Yes, so simply you can say, because that may be the first question. If you will tell that, yes, sir, I know basics of Scikit-learn library, so they will ask that why we use this Scikit-learn library. So simply you have to tell that whenever we want to use machine learning techniques, we want to create a machine learning model, okay, in our project. If we want to use machine learning algorithms, then we have to use Scikit-learn library. For fetching data, as you told, okay, Deepika. So for fetching data, we can directly use that pandas library also, okay. For only manipulation of data, we can do this thing with pandas library also. But whenever we want to include machine learning algorithms, okay, in our project, then we use this Scikit-learn library. I hope this point is clear.
yes, sir.
So with the help of NumPy, we can't do machine learning algo projects only with the help of NumPy. Okay, only with the help of pandas we can't do machine learning projects. But with Scikit-learn library, in addition to pandas and NumPy, we can do machine learning projects. So as you can see, this was one of the, we can say, simple machine learning project, because that machine learning project may involve more than one machine learning algorithms. Like we use decision tree, so it may involve any other machine learning algorithm like SVM or any other one, or it may use any ensemble approach like 2 or 3 algorithms it can use in one project, in one model we can use. Okay, So that may be a bit complex, okay, or a bit lengthy, we can say. But if you want to use machine learning techniques, then we can use this Scikit Learn library, okay.
Yes, sir, we understood. Sir, I have one small doubt.
Yes.
Sir, this decision tree algorithm, is it a supervised learning algorithm, sir? I
Decision
mean,
tree
comes under
algorithm.
super. Yes.
Yes, yes, yes.
So we can take any classifier like regression or any
Yes,
method
yes,
we
yes,
can.
yes, yes. We
So,
can take. So let
uh,
me tell you.
so can
First, you asked the question. Let me confirm that thing, that in supervised learning, you can see we have decision tree. Okay. So in supervised learning, if that problem is classification problem or whether it is a regression problem, we can use decision tree. Okay. But decision tree is itself a supervised learning algorithm. Okay. I hope you got this answer. Next, what you asked.
So suppose we want to use the regression analysis,
Okay.
it may be the linear regression.
Okay.
So so how we are getting the command and all, like we now we used that is decision tree.
Hmm.
So how like if it is a regression and linear regression, then how we are going to write the command and details?
Okay, let me tell you that in Sklearn library for regression problem. First of all, let me tell you one thing, that for iris data set, it is a classification problem. Okay, so we can't use regression for that problem. Okay, for this iris data set. But if we have another problem that is a regression problem, so we can use these regression algorithms. Okay, so in which if you want to use this linear regression algorithm, for that we have a function in Sklearn, so that we have to import and then we can use. So let me show you that how we can import. So in Sklearn we have this linear regression. Okay, in Sklearn linear regression. So you can go to the official website for Sklearn linear model dot linear regression. Okay. So that we have to import first, and same that CLF we will build, and that fit we will use. Okay. Same, in the same way we can use. Or if you want to see, for example, uh, here. So for regression also same, from sklearn.linear model import linear regression. Okay. First we have to import and then we can use this linear regression function. Okay. Dot fit means that fitting, which means training our data. So like that we can use. Okay.
Yes, sir. So this is the command. Then suppose we have some data
Hmm.
and we want to optimize the data. Suppose like it's having some gain, some noise figure. So we want to optimize the data. Suppose we want to find some gain, maximum gain, minimum gain,
Okay.
like that.
Okay. Okay. Okay.
So we want to fed the data by using the linear regression analysis. Then how we are going to import that? Suppose first of all we are going to import the data in the, suppose it is in the Jupyter notebook, we have imported it.
Okay.
Then
Fine.
after we are writing this, and after
Okay.
that what to do?
So let me tell you, if that is a noisy data, so we have to do some pre-processing. Okay. So pre-processing may involve, even Sklearn has some, we can say, modules for pre-processing also. So let me go to the official website where I will show you that how we can optimize. Okay. So for classification, we can use, as I told you, okay, that we used decision tree. So classification we have, regression we can do, clustering also we can do, dimensional tree reduction, model selection. For model selection also we can use, we have some functions in Sklearn. For pre-processing, for example, feature extraction and normalization that you actually asked, so that also we can do. Okay, in which what we have to do, actually let me tell you, that feature extraction we can do. It means simply what we will do, we will use some functions like dictionary vectorizer. Okay, and different type of feature selection concepts we have, like for example, for feature selection we have correlation concept, and we have chi-square concept. Okay, so chi-square algorithm. So these type of different algorithms we have to use. So I hope you are asking this thing.
No,
So
sir, we are not going to extract something. Actually, we have some data. So,
okay.
in that particular data, suppose I have data from 100 to 10, and
Hmm.
I want to find out the 100 is the maximum, 10 is the minimum. Okay,
Okay.
so these things I am going to use the supervised learning. So, that is suppose linear regression analysis I am using.
Okay. Okay. Okay.
So how it is going to find out? Already the data is there, maximum, minimum data. So
Okay.
the algorithm it is going to find out which one is the maximum and which one is the minimum.
Okay. Okay. So let me tell you that first of all, what is maximum and what is minimum, if you want to find out, okay, that problem will not directly come under machine learning domain. Okay, that will be a simple, we can say, program problem that will not come directly under this machine learning problem, machine learning domain. Okay, if you want to find some maximum or minimum among some values. Okay, so we don't need to use, we can say, we can use, but we don't need to use for these type of simple problems. So it is better when we have to predict something, okay, on the basis of a lot of data, then we should use machine learning.
Sir,
Otherwise,
same thing, sir. I'm asking. It's a big data.
okay,
Suppose it's having 100 channels. So how to find out the maximum one? So in that case, we have to use some algorithm.
okay, okay,
So
okay,
I'm just giving given one example for
mm,
that how to find the maximum and minimum, but that is the big data.
okay,
So we how we are going to find out something? Suppose we are using the regression analysis,
okay.
then it is going to face that whatever the input data, and it is predict
So
that
let
output.
me show you one thing that we can do. For example, house price prediction. Okay, so for example, if you have a data set, okay, using linear regression, and in Sklearn you want to use, and Python also you want to use. So just for carry on the discussion, I am going to take one example. Okay, let me show you. Okay, let me show you that how we can use this linear regression. So first of all, we have to do so. From sklearn.linear model, import linear regression. Okay, this import you have to use. Then linear regression function you have to use, in which for normalization you have to provide this as true. Normalize is equal to true. So that are actually learning parameters for different classifiers. Okay, for decision tree classifier we don't have direct any direct learning parameter, but for linear regression we have this one. And then again fit function you have to use. So like that we have to use linear regression. I hope you are asked, you want to know this thing
Yes,
or
sir.
anything
Yes, sir.
else.
I understood that, sir.
Hmm.
After that, then how we are going to import? Like already it is imported. We know that procedure.
Okay.
Okay, so
Hmm.
after running, we'll get the whatever the
Yes, yes, yes.
using the
Then,
regression analysis. Okay,
so that is the actually scope of machine learning. That through machine learning only you can do these type of things. If you
okay,
want to create new data, so in that case you have to go for different type of, for example, deep learning. Okay,
mm,
so in that we have GAN's concept. So but that is beyond the we can say scope of simple machine learning algorithms.
understood, sir.
So with the help of these machine learning algorithms, especially linear regression classification, so we can do this thing. So we will fit, okay, or we will train our data set. Then we can do model evaluation. It means accuracy and other parameters we can know. And then after that, we can do directly prediction that for these values, what will be the final value or target value. Okay, so we
Yes, sir,
can
I
do this
understood.
thing. Okay, so this was the basic concept of Scikit Learn library, in which we discussed the classification problem on iris dataset. But let me tell you again that each classifier, like each algorithm, if you will go in detail, then there will be a lot of things that you need to know. So what you can do, you can keep this diagram. I will share this diagram with you. So if you are going to learn all the basic things about these diagrams, then you can say that you have learned the basics of machine learning. Okay, but here we are actually dealing especially the things about Python programming. So but the Scikit Learn library we use for machine learning models, that's why I use this thing. But a lot of things, okay, are there that we need to learn if we will go for machine learning. Okay, but here we have discussed only, we can say, the superficially we have discussed the things, or we can say at upper surface only we have touched the things. Okay, so that's it for today's session. Thank you, thank you so much.
Thank you, sir.
Thank you, sir. Good night.
Thank you, bye.